All right, let's get started. Today, we're going on a huge tour of our cosmic neighborhood, the solar system. We're going to journey from its blazing hot center all the way out to its coldest, most distant edges. So, let's dive in. But first, before we blast off, here's a little something to chew on. True or false? The sun is a static, unmoving object right in the middle of everything. What do you think? Keep that answer in your back pocket because by the end of this, you might be surprised.
So what even is the solar system? Well, when you boil it all down, it's our sun and everything that's stuck to it by gravity. We're talking planets, moons, asteroids, comets, the whole shebang. Gravity is really the invisible string that holds this entire cosmic family together.
Now, to really understand our neighborhood, we've got to go back in time. And I mean way back, about 4.5 billion years, to see how this whole place was put together.
You see, it all kicked off with something called a solar nebula. Just imagine this giant swirling cloud of gas and dust. And then gravity, the master builder of the universe, starts to pull it all inward. As it collapses, it spins faster and faster, flattening out into a disk, kind of like a spinning pizza dough. Most of that stuff got sucked into the center and got so hot it ignited into our sun. And the rest? Those little particles started bumping into each other, sticking together and building the planets. All the leftovers became the moons, asteroids, and comets we have today.
And that's our first stop on the tour. Everything, and I mean everything, begins right there at the center with our star, the sun.
The sun's dominance is just mind-blowing. First off, it's not solid. It's a massive ball of superheated gas we call plasma. And get this, it's so big, it makes up 99% of all the mass in the entire solar system. That incredible weight is what creates the gravity that keeps all the planets locked in orbit. And all its power comes from nuclear fusion happening in its core, where temperatures hit a ridiculous 15 million degrees Celsius. Okay, moving outward from the sun, our first group of stops is in the inner solar system. This is home to the rocky worlds: Mercury, Venus, our home planet Earth, and of course, Mars.
We call these terrestrial planets. And that name comes from the Latin word terra, which literally means earth. It's a perfect name, because just like our world, they're all made of rock and metal. They have a solid surface you could, in theory, walk on.
Now, as we travel between these planets, the distances get absolutely enormous. Using kilometers or miles is like trying to measure the ocean with a teaspoon. So astronomers came up with a better yardstick, the astronomical unit, or AU. 1 AU is just the distance from the Earth to the Sun, about 150 million kilometers. It makes mapping our cosmic backyard so much easier.
All right, after Mars, we hit a major landmark, the asteroid belt. This is this huge ring of millions of rocks and chunks of ice that forms a natural dividing line in our solar system. It separates the small, rocky inner planets from the absolute giants of the outer solar system.
And while we're here, let's clear something up that gets people confused all the time. Asteroid versus comet. What's the deal? It really just comes down to what they're made of. Asteroids, like the ones right here in the belt, are mostly rock and metal. Comets, on the other hand, are more like dirty snowballs. They're made of rock and ice. And when a comet gets close to the sun, that ice heats up and blasts off, creating that famous, beautiful tail.
And speaking of space rocks, ever see a shooting star? Well, here's what's actually going on. When that little piece of rock is just drifting through space, it's a meteoroid. If it hits Earth's atmosphere and burns up, that beautiful streak of light we see is called a meteor. But if a piece is tough enough to survive that fiery trip and actually hits the ground, it gets a brand new name, a meteorite. It's the same rock, just with a change of address.
Okay, let's punch it. We're crossing the asteroid belt now and heading into the realm of the giants: Jupiter, Saturn, Uranus, and Neptune. And out here, you can really see the two very different planetary families we have. You've got the inner worlds, small, dense, and rocky. And then you have the outer worlds. They are huge, way less dense, and mostly made of gas and liquid. But one of the biggest, most dramatic differences, just check out how many moons they have. The difference is just staggering. Earth has its one lonely moon, but the gas giants, they have dozens. Jupiter's got nearly 80 known moons, and Saturn has over 80. Their ginormous size gives them so much gravity that over billions of years, they've just scooped up and captured all these other objects into their orbit.
And when you add them all up across all the planets, our solar system is home to more than 200 known moons. This place isn't just a simple set of 8 planets. It's this breathtakingly complicated, dynamic system of systems, all dancing around each other through space. Okay, for the last leg of our trip, we are pushing out to the very edge of the sun's reach, into the dark, frozen frontier of our solar system.
Way, way out beyond the planets, there are these 2 gigantic reserves of ancient icy objects, basically the leftover building materials from the solar system's birth. First up is the Kuiper Belt. It's a huge donut-shaped ring that kicks off just after Neptune. And then, even farther out, is the Oort cloud, this massive spherical shell that completely surrounds our entire solar system. The easiest way to picture the difference is by their shape and size. The Kuiper Belt is like a flat, icy donut orbiting with the planets. The Oort cloud, though, is a colossal sphere, a giant bubble that wraps around everything else. And it's from these 2 super distant places that most comets start their long, long fall toward the sun. So, where does everyone's favorite dwarf planet Pluto fit in? Well, it's not some lonely wanderer. Pluto is actually one of the biggest objects we know of in the Kuiper Belt, so it's right at home out there, giving us a familiar landmark in this cold, mysterious region. And that brings us all the way back to where we started. After taking this massive tour of everything that orbits the sun, let's dust off that first question. Is the sun itself actually standing still? The answer is a definitive false. Nope. Even though it's the center of our solar system, the sun is anything but static. The sun, and our entire solar system along with it, is actually rocketing through space, making one giant lap around the center of our Milky Way galaxy, a lap that takes about 230 million years to complete.
So, our entire cosmic home is on its own epic voyage. We've finished our tour for today, but it does leave you with a pretty cool final thought, doesn't it? We've mapped our home, but what other incredible secrets are still out there, just waiting for us, hiding in the dark between all these worlds?